Of Honors Algebra 2 Pre-Calc. We are doing vectors in a plane. What we're going to talk about in this video is standard position. Okay, so I'm going to draw a vector that starts at 2, 1 and ends at 5, 2. Okay, so I'm going to call that vector A, B. So A is 2, 1 and B is 5, 2. Okay, so this is my vector AB, right? So essentially, if I were to draw AB, I could draw AB anywhere, right? I could find the magnitude of AB by using that distance formula, which we'll do in a sec. But what I want to show you is I want to show you a comparable vector that I'm going to call PQ, 1, 2, 3, 1. Okay, so PQ starts at the origin and ends at the point 3, 1, right? So what I want to put out, and I didn't do a great job of drawing exactly the same scale here, but what you'll notice is vector AB, right, goes over 1, 2, 3 units and up 1 unit to get to B, right? So over 3, up 1. And what I want you to notice is vector PQ does the same thing. You go from P to Q by going right 3 units and up 1, right? So essentially, these are the same vector. They have the same magnitude and direction. They're the same length. Again, I didn't do a great job of drawing them at the same scale, but they're the same length. And they go exactly the same direction, meaning that they both point 3 units right and 1 unit up. So these are the same vectors. AB is just any old generic vector, but PQ is in what we call standard position. So they're the same vector, right? The difference is that PQ is that it starts its initial point at the origin, and that's what we call a vector in standard position. So AB is not in standard position, but they're the same vector, right? They're the same magnitude. They're the same direction, right? The same length and the same length or size, and they point in the exact same direction, right? Which is right 3, up 1. So AB and PQ have the same magnitude and direction. For all intents and purposes, they are the same vector. So what we're going to do now is we're actually going to do an example, and I want to prove to you that they have the same magnitude. So let's actually find the magnitude of both of these, right? So we're going to go ahead and, again, the difference is that this vector is in standard position, this one is not, right? And we can talk about in a second ways that we can write things in standard position that we can't necessarily write things in a non-standard position. So for example 1, we're going to find the magnitude of AB, and we're going to find the magnitude of PQ, right? And they're going to be the same, right? So if I wanted to find the magnitude of AB, right, the magnitude of AB is essentially the distance formula where I do the x-coordinate minus the x-coordinate, so that's 5 minus 2 quantity squared, plus the y-coordinate minus the y-coordinate, which is 2 minus 1 squared. I'm going to get this as a square root of a 9 plus a 1, so I get root 10. And if I do the same thing with the magnitude of PQ, it's going to be the square root of, well, now one of my coordinates is 0, right? So now it's 3 minus 0 quantity squared, but I could also just cheat and do the 3 squared because I see that it's a 0, and a 1 minus 0 quantity squared. So sure enough, I again get a 9 plus 1, which means I get root 10. So what I want you to notice is they have the same magnitude. And again, the reason they have the same direction is essentially, for lack of a better way to say it, their slope is the same. The rise over run is the same. So that's the gist of why they have the same magnitude and direction. These vectors are equal. They're just physically in different spaces, right? Same magnitude, same direction. Okay, so PQ can be named in a different way. So when we talk about PQ, we can actually use a thing called component form. So component form of a vector, right? So, and this is my personal preference of how to write vectors, but we're going to talk about, so component form of a vector, so we'll say vector V, which is in standard position, right? So it's in standard position, meaning that its initial side is at the origin, right? Vector V can be written, and when we do vectors with these, sort of a grouping symbol, just like we use parentheses for points, and we use braces or curvy bracket sort of things for lists, and we can use parentheses and brackets when we're talking about inequalities for excluding or including endpoints. When we do vectors, we use these pointy brackets that kind of look like less than or equal to signs. So instead of a parenthesis, we use this pointy bracket, right? And V1 is the x-coordinate or the x component, right? And V2 would be the y component. Meaning that in this situation, I could write the vector PQ, because it's in standard position, I could write it as 3, 1, right? And if I wanted to find the magnitude of V, because it's in standard position, just like we saw in this example, I didn't really have to do 3 minus 0 because if something's in standard position, the other coordinate is 0. So I could have just done the square root of v sub 1 squared plus v sub 2 squared, which again would have given me that same 9 plus 1, which is a root 10. So this is component form. In general, we're going to want to deal with vectors in standard position whenever possible because they're easy.